Have quite a topic today. It's one that stretches from the very nature of our own thoughts all the way out to the biggest things we see in the universe.
It really does bridge those scales. And the listener's question hits the nail on the head. We're looking at the phase-shifting universe, model PSUMOT, and asking, okay, does this new evidence about how consciousness seems to emerge, does that actually back up the model?
Right. And if it does back up the model on that sort of human scale, what does that mean for its really huge predictions, like but the great attractor out there in space?
Exactly, because PSUMOT isn't just tinkering around the edges, it's proposing a fundamental rewrite. It says consciousness, the cosmos. They aren't totally separate puzzles. They both emerge from the same basic stuff.
And that basic stuff is superfluid dark matter.
That's the core concept. Forget empty space. PSUMOT says the universe is filled with this quantum superfluid. That's dark matter, the substance. And dark energy, that's not some extra thing added in. It's just the motion, the flow, the current of that same fluid.
Okay, so it's like a cosmic ocean instead of a vacuum?
Precisely. A dynamic hydrodynamic system. So the mission for us today is to see if this holds water, First, we need to check if the core idea emergence is actually seen in the real world, like in labs.
And then, the really tricky part, does PSUMOT predict things about consciousness, about how our minds work, that we're now finding evidence for in neuroscience?
Yes. Because if the model gets consciousness right, this incredibly complex local thing, then maybe, just maybe, we can trust its predictions about the vast cosmic structures, like the Great Attractor.
Okay, that's a huge task. So where do we start? With the big picture, the cosmology.
I think we have to. We need to understand what PSUMOT is trying to replace. The current standard model, lambda-CDM, well, it's got some serious problems.
Yeah, our sources definitely paint a picture of a model in crisis. It's not a minor issue, is it?
Not at all. Lambda-CDM, that's lambda cold dark matter, it works, sort of, mathematically. It fits the data we see, but it feels patched together. It wasn't built from the ground up. It was assembled piece by piece after we made observations to make them fit.
Like building a boat while it's already sinking and plugging the leaks as you find them.
That's not a bad analogy, actually. And the biggest leak, the one everyone points to, is the cosmological constant problem.
Ah, yes, the worst fine-tuning problem in physics. I've heard that phrase.
It sounds dramatic, but it's accurate. The issue comes from quantum field theory, QFT. It predicts that even empty space, the vacuum, should be buzzing with energy virtual particles popping in and out of existence.
Okay, so space isn't empty. It has energy.
Yeah.
That sounds like it could be dark energy, right?
That was the hope. But when physicists actually calculate how much energy should be there based on QFT, using standard assumptions like the Planck scale as a cutoff, the number they get is insane.
How insane are we talking?
We're talking 120 times bigger, one followed by 120 zeros. That much energy compared to what we actually observe driving the universe's expansion.
Wait, 120 orders of magnitude? If that energy was real, the universe would have, exploded instantly?
Pretty much, yeah. It would have ripped itself apart fractions of a second after the Big Bang. So for the standard model to work, physicists have to basically say, okay, let's assume there's some other effect that perfectly cancels out almost all of that massive vacuum energy, leaving just the tiny bit we see.
That sounds artificial, like cooking the books.
It's incredibly artificial. It requires fine-tuning this cancellation to an unbelievable degree of precision. It strongly suggests the basic assumption that static vacuum energy drives expansion is just wrong.
Okay, problem one. The cosmological constant disaster. What's next? The coincidence problem.
Right. If dark matter and dark energy are totally separate things, as lambda-CDM assumes, isn't it a bit weird that right now in the universe's long history, they happen to have roughly the same density?
Yeah, why now? Why not billions of years ago or billions of years in the future?
Lambda-CDM has no explanation. It just says, well, that's just how it is. A cosmic coincidence, which scientifically is deeply unsatisfying.
And then there's the one making headlines more recently, the Hubble tension. So this is about how fast the universe is expanding, right?
Exactly. It's a direct conflict in measurements. When we look at the early universe using the cosmic microwave background radiation, the echo of the Big Bang, we measure the expansion rate, called the Hubble constant, or H$, to be around 67 kilometers per second per megaparsec.
Okay, 67. That sounds precise.
It is. But when we measure the expansion rate locally, looking at things relatively nearby, like pulsating stars called Cepheid variables or certain types of supernovae.
Those standard candles that tell us distance.
Precisely. Using those, we consistently get a higher value, around 73 kilometers MPC.
So 67 versus 73, That doesn't sound like they agree within error bars.
They don't. It's a significant tension. The standard model, tuned to match the early universe's 67, can't explain why things seem to be expanding faster nearby. It suggests something fundamental is wrong with our understanding of either the early universe or the local universe, or both.
Okay, so the standard model is creaking. It's got the constant problem, the coincidence problem, the tension problem. It feels like it's begging for a replacement.
And this is exactly where PSUMOT steps in, offering solutions that arise naturally from its core idea, the superfluid universe.
How does it tackle the coincidence problem first?
It just dissolves it through unification. Remember, in PSUMO, dark matter is the fluid substance, dark energy is its motion. They aren't separate things. They're two aspects of the same thing.
Ah, so it's not a coincidence they have similar densities now. It's just a phase in the fluid's evolution.
Exactly, like a river system evolving over time. Early on, the substance aspect might dominate. Later, the flow aspect becomes more prominent. It's a natural progression, not a fluke.
Okay, that's neat. What about the disastrous cosmological constant calculation?
PSUNO bypasses it entirely. It says the accelerated expansion isn't caused by some weird energy of empty space. It's caused by the dynamic negative pressure generated by the large-scale flow of the superfluid itself.
Negative pressure, like how the shape of an airplane wing creates lift, the Bernoulli effect.
A very similar principle, yes. Large-scale fluid flow can generate regions of lower pressure, and in cosmology, that negative pressure drives expansion. Energy calculations that are off by 120 orders of magnitude. The fluid dynamics handle it.
That feels much cleaner. So the Hubble tension, does the fluid model predict that?
It actually predicts it. Think of the superfluid universal current as a vast river flowing through the cosmos. Now, what happens when you put big rocks in a river?
It creates turbulence, right? Eddies, faster flowing water around the rocks.
Precisely. In PSUMOT, massive structures like galaxy clusters or even our own Laniakea supercluster act like those rocks in the river. They create localized turbulence in the superfluid flow.
So we, living in our local part of the universe, are basically in one of those turbulent, faster-flowing sections.
That's the idea. Our local measurement of 73 kilometer MPC reflects this faster local flow, while the 67 kilometers MPC from the early universe reflects the smoother average flow before these large structures fully formed and disrupted it. The tension isn't a problem, it's evidence for the hydrodynamic model.
Wow, okay. That turns the problem on its head. So let's apply this fluid logic to the really big rock, the Great Attractor, this enormous region pulling galaxies towards it. How does PSUMO see that?
First, we have to adjust how we think about gravity itself. In PSUMOT, gravity isn't fundamental space-time curvature in the Einsteinian sense. It's an emergent force.
Emergent, meaning it arises from the fluid dynamic.
Exactly. Matter, which is itself a kind of condensed state or disruption in the superfluid, creates drag. It creates localized eddies and wakes in the universal current.
Okay, but hold on. If gravity is just drag or pressure differences, how does that create the stable orbits we see? Why doesn't everything just get pushed into clumps? You mentioned this idea of acoustic gravity. Gravity is a push. That sounds counterintuitive. Doesn't gravity pull?
That's a really crucial point. It feels like a pull, but the mechanism PSUMOT proposes is based on pressure gradients. Think of it like this. Where you have a lot of matter, it disrupts the superfluid, creating a region of lower pressure like a drain sucking water down.
Okay.
The surrounding superfluid, which is at a higher pressure, then pushes other matter towards that low pressure zone, so matter gets pushed together.
But the orbits, the inverse square law, the way gravity seems to curve spacetime.
The push isn't uniform. The pressure gradient is steepest near the mass concentration and falls off with distance, mimicking the inverse square law. And the path of least resistance through this varying pressure field is the effective geodesic, the curve that objects follow. So the fluid pressure landscape effectively replicates the geometry of curved spacetime, leading to stable orbits and structures like galactic halos.
So the dark matter halos around galaxies. PSUMO sees those differently too.
Yes. Halos aren't just invisible mass creating a gravity well. They are the region where the superfluid itself is most intensely dragged and concentrated by the visible matter, creating and reinforcing that local low-pressure eddy. The halo is the localized fluid disruption.
Which brings us back to the Great Attractor, composed of the Norma, Shapley, Vela superclusters.
Yeah.
It's not just a mysterious gravitational anomaly anymore.
In PSUMOD, it's exactly what you'd expect from large-scale fluid dynamics. It's a huge region where the massive concentration of matter from those superclusters creates a significant long-range superfluid disruption, a vast area of low pressure.
Like a cosmic sinkhole.
A perfect analogy, a giant persistent sinkhole or eddy in the universal current, whose lower pressure effectively pulls, or rather pushes matter towards it over immense distances, explaining why our galaxy and others are moving towards that region. It turns a cosmological puzzle into a natural outcome of the fluid model.
Okay, the cosmological picture seems coherent, at least theoretically, but it all hinges on this idea of emergence. Can we actually see emergence happening? Can we prove it's a real mechanism?
Absolutely. Emergence isn't just a philosophical idea. It's a core principle in physics and complex systems. It's simply the observation that when you put lots of simple things together, they can start behaving in complex ways with totally new properties.
Like water molecules are simple, but put enough together and you get wetness, waves, flow, properties the individual molecules don't have.
Exactly. Or think about the economy. You don't predict market crashes by tracking individual atoms in traders' brains. You look at emergent properties like interest rates, investor confidence, supply chains. The higher-level system has its own rules that screen off the micro details.
So we need some concrete proof that this happens, especially bringing quantum mechanics to large-scale effects, like PSUMO needs.
And the sources point to a fantastic laboratory example: high-pressure superconductors. This is where we can literally see matter being forced into macroscopic quantum states, just like PSUMO proposes for the universe.
Superconductivity. That's where materials lose all electrical resistance, right?
Yeah.
Usually super cold temperatures.
Typically, yes. But the key here is high pressure. Superconductivity itself is an emergent phenomenon. You take simple elements, squeeze them under incredible pressure, millions of times atmospheric pressure.
And something new emerges.
Yes. The intense pressure forces the atoms in the material's crystal lattice so close together that their electrons start behaving collectively. They overcome their mutual repulsion and form Cooper pairs.
Cooper pairs. Two electrons acting as one unit. How does pressure do that?
The pressure modifies the vibrations in the lattice with the phonons. These vibrations act like a glue that binds electrons together into Cooper pairs. These pairs can then move through the lattice without resistance. It's a collective quantum mechanical state emerging from pressure.
And scientists have achieved this near room temperature.
They have, especially with materials like hydrogen-rich superhydrides under extreme pressure. They've created materials that are essentially macroscopic quantum objects, superfluids, or superconductors in the lab.
So the lab confirms you can force matter into these large-scale quantum states using pressure.
Which lends huge credibility to PSUMOT's core idea. If pressure can create emergent quantum superfluids in the lab, it makes the idea that the entire universe is a kind of cosmic scale superfluid with properties like gravity emerging from its pressure gradients seem much less outlandish. It validates the mechanism.
Okay, mechanism validated, at least in principle. Now for the really big leap, applying this to consciousness. This is where the listener's question gets really specific. Did PSUMOT make predictions about the brain that are now being confirmed?
It did, and it was a pretty counterintuitive prediction. PSUMOT suggested the brain doesn't generate consciousness from scratch. Instead, it acts more like a complex receiver, or maybe a filter, or a processor.
A receiver. Receiving what?
Receiving information or accessing a more fundamental field of consciousness that permeates the universe, potentially linked to the superfluid substrate itself.
That sounds like Aldous Huxley's idea, the reducing valve.
Yeah.
The brain filters out a torrent of information, mind at large, leaving just what we need for survival.
Exactly that concept. And interestingly, modern cognitive science is increasingly seeing perception not as a passive recording, but as an active construction, a controlled hallucination.
Controlled hallucination, meaning our reality is basically the brain's best guess.
In a way, yes. Your brain uses past experiences, expectations, and internal models to interpret the noisy, ambiguous data coming from your senses. Think about optical illusions, like the hollow rotating mask. You know it's hollow, but your brain insists on seeing a normal face because faces are usually convex.
Or the Kuleshov effect in films showing the same neutral face after different images makes us see different emotions on the face.
Right. The brain is constantly filtering, interpreting, constructing our reality based on priors. This fits perfectly with the idea of it being a processor or filter, translating some fundamental input into our familiar classical experience.
But PSUMO went further, didn't it? It made a very specific prediction about language.
Yes. This is the crucial link. PSUMO predicted that linguistic categorization, the act of naming or describing something, functions like a quantum measurement. It forces a fuzzy, unified neural state to collapse into a distinct classical category.
Language is measurement. Collapsing brain states. That's a wild idea. Is there actual neuroscience evidence for that?
This is where the new evidence comes in, and it's fascinating. It focuses on experiences that feel similar but have different names, specifically nostalgia and déjà vu.
Okay, nostalgia, warm feeling about the past. Déjà vu, eerie feeling of having lived this moment before. They feel very different.
Linguistically, yes, we treat them as poles apart. But when neuroscientists looked at brain activity during these experiences using advanced imaging, they found something remarkable.
What did they find?
Despite the different labels and subjective feelings, nostalgia and déjà vu showed a massive 70% overlap in the brain regions they activated. Regions involved in memory recall, emotional processing reward, and figuring out time-temporal bindings.
70% overlap.
Uh-huh.
So neurologically, they're mostly the same thing.
It gets even more specific. They found that both experiences exhibit identical patterns between theta and gamma waves.
Theta and gamma. What do those signify? Can you break that down?
Sure. Think of theta waves, around 4 to 8 cycles per second, as the brain's internal clock or sequencer, crucial for organizing memories in time and navigating space. Gamma waves, much faster, 3,100 plus cycles per second, are associated with binding different features of an experience together into a coherent whole, like combining the sight, sound, and feeling of an event.
So finding the same theta-gamma coupling in both nostalgia and déjà vu means?
It means the underlying neural machinery being activated is the same. It's a core system in the brain dealing with memory, time, and familiarity, trying to place an experience, perhaps an ambiguous one, within our personal timeline and emotional context.
Wow, so the brain has this unified process for handling these kinds of temporal memory glitches, but our language forces us to chop it up and label the outcomes as nostalgia or déjà vu, even though the underlying process is shared.
That's exactly the interpretation. The experience itself might be on a spectrum, a kind of superposition state, but the act of labeling it, of forcing it into a predefined linguistic box, collapses it into one distinct classical feeling or the other. Language acts as the measurement tool.
And this linguistic measurement, does it have wider effects? Does it create biases?
PSUMOT suggests it does, especially at a collective level. When we all use the same fragmented language to discuss these fuzzy, ambiguous experiences, that shared linguistic framework acts like a collective measurement, potentially creating systematic biases or even shared false memories.
Are you talking about things like the Mandela effect, where large groups of people misremember details about movies, logos, historical events?
That's a potential example, yes. Think of the Berenstain Bears versus Berenstain Bears spelling debate. Huge numbers of people swear they remember the EI spelling, even though all evidence shows it was always AI.
So the theory would be the collective memory was initially in a kind of fuzzy superposition state regarding that minor detail. But the widespread discussion and categorization using one label versus the other acted like a measurement, collapsing the memory state for many people into a fixed but incorrect classical memory.
That's the line of reasoning suggested by applying PSUMOT's linguistic measurement idea. It implies that our collective consciousness, shaped by shared language, isn't just passively observing reality, but actively participating in collapsing possibilities into a shared classical consensus.
Okay, that's profound. If true, it means the way we talk about things literally shapes the reality we collectively experience, at least at the level of memory and perception.
And crucially, it provides empirical validation for PSUMOT's prediction about consciousness. The brain as a receiver filter, translating underlying quantum-like information, with language acting as the measurement apparatus that forces classical outcomes.
Right. So let's bring this all together. We've looked at the problems with the standard model, how PSUMOT's fluid dynamics offers solutions on the cosmic scale.
We've seen how the core mechanism, emergence, is validated in lab experiments with superconductors.
And now we have this neuroscience evidence seemingly confirming PSUMOT's specific, non-obvious predictions about how consciousness, language, and brain function interact.
Exactly. The chain of validation seems to be holding. Mechanism works, emergence. Model predicts specific conscious phenomena. Those predictions are confirmed by new data.
So going back to the listener's original question, how does this validation on the scale of consciousness affect our confidence in PSUMOT's cosmological claims, like about the Great Attractor?
It increases confidence significantly. If the fundamental principles of the model emergence from a unified substrate, pressure dynamics, measurement-induced collapse, are proving accurate in describing something as complex and delicate as human consciousness and memory.
Then it's much more likely those same principles are correctly describing the larger-scale emergent phenomena, like gravity and cosmic structure.
That's the logical inference, yes. The model's structural integrity seems sound across vastly different scales. It successfully predicted a subtle effect within the human brain. That success lends considerable weight to its predictions about large-scale structures governed by the same underlying physics.
So we can infer with more confidence now that the great attractor probably isn't just some unexplained gravitational heavyweight that Lambda's Thidm struggles with.
But rather, it's likely a direct predictable consequence of PSUMOT's superfluid dynamics. It's that massive eddy or wake, that large-scale pressure minimum in the universal current, generated by the immense matter concentration of the Shapley and Vela superclusters pulling things towards it via pressure gradients.
What was a cosmological crisis becomes an expected feature of the cosmic river.
Precisely. The same physics governing Cooper, pairs in a lab, and theta-gamma binding in the brain scales up to explain the flow of galaxies across the universe. It's all emergence from the underlying superfluid.
That's quite a journey we've taken them, from the tiniest scales imaginable.
Yeah, you mentioned electron tychography earlier, imaging things down to, what, 0.03039 angstroms? Practically seeing atoms.
All the way up to the great attractor, spanning hundreds of millions of light years, and potentially linked by this single theoretical framework.
The unifying thread beyond the physics itself seems to be about perspective, about parallax.
Parallax, like how astronomers measure the distance to stars by observing them from different points in Earth's orbit. The shift in perspective gives you the depth.
Exactly. You need that shift, that different viewpoint to get an accurate picture. Relying on just one angle gives you a flat image.
And the sources suggest this applies psychologically too, like analytical psychology using the conscious versus unconscious, or self versus shadow as different perspectives to understand the whole person.
Yes. If you only see through the single lens of your everyday survival-focused consciousness, that reducing valve we talked about, you're getting a necessarily limited, potentially distorted view. The nostalgia déjà vu example shows how our chosen perspective, our language, literally shapes what we perceive as distinct realities.
Which leads to that final, really mind-bending idea from thinkers like Zizek mentioned in the sources. If reality is constructed, filtered information, and changing our way of knowing it, our epistemology,
can actually change the thing itself, its ontology, its very being.
then what happens if we consciously try to adopt this parallax view? If we actively challenge the single perspective narratives, the linguistic boxes?
If PSUMOT is pointing in the right direction, and if our way of observing and categorizing does influence the collapse into classical reality, then maybe changing our collective perspective, embracing multiple viewpoints, resisting those easy fragmentations, maybe that doesn't just help us understand reality better.
Maybe it helps us co-create it differently. A more unified reality.
That's the provocative thought, isn't it? If consciousness is truly participatory, if changing how we see changes what is, then maybe the work of understanding the mind and the work of understanding the cosmos are fundamentally intertwined. Maybe internal work has external consequences.
Psychology is cosmology. That is definitely something to mull over.
Yeah.
A fascinating deep dive today.